Let's look at the cubed root function. If you make a table of values for y equals the cubed root of x, you're going to see that when x is negative 8, y is negative 2. When x is negative 1, y is negative 1. When x is 0, y is 0. When x is 1, y is 1. And when x is 8, y is 2. So you get this kind of shallow S-shaped curve. When you want to do transformations on the cubed root function, the exact same processes apply. The cubed root of x plus d, if d is positive, it's a vertical shift up d units. If it's negative, it's a vertical shift down by d units. If you have the cubed root of x minus c, where the c is under the radical there, it's a shift to the right when c is positive, and it's a shift to the left when c is negative. If I have a constant multiplied on the outside and it's greater than 1, it's going to be a vertical stretch. So it's going to stretch it that way. If a is the absolute value of a is between 0 and 1, it's going to be a compression. It's going to shrink it. And of course, if a is negative, it's going to reflect it across the x-axis. Well, if that constant is there next to the b and it's greater than 1, it's going to be a compression, a horizontal compression. Remember, the vertical stretches and the horizontal compressions can be equivalent. If b is between 0 and 1 in magnitude, it'll be a horizontal stretch. And when b is negative, it's going to reflect across the y-axis. Now let's look at this table of squares and square roots. 1 squared is 1, so the square root of 1 is 1. 2 squared is 4, so the square root of 4 is 2. 3 squared is 9, so the square root of 9 is 3, etc. We're going to do the same thing for the cubes. 1 cubed is 1, so the cubed root of 1 is 1. 2 cubed is 8, so the cubed root of 8 is 2. 3 cubed is 27, so the cubed root of 27 is 3, and so on. I do want you to know this entire table up to 12 cubed. I want you to be able to find the cubed root of 1728. Realistically, in most of your homework problems, you probably won't go much above 6, so you may have to work a little bit on memorizing these. Now, suppose I have a horizontal shift, and let me look at the function y equals the cubed root, of x plus 2. All right, this is going to be a horizontal shift to the left, 2 units. Now, what you're going to want to do is find where this is 0. This is going to be your inflection point, and you always want to graph your inflection point. So x plus 2 equals 0 when x is negative 2. So I'm going to do my graph, x, y. All right. Now, when x is negative 2, y is the cubed root of negative 2 plus 2, where it's 0. So that's going to be an easy point to graph. Now, the next thing you're going to do is find a couple of points on either side of your inflection point to give you a general shape of the graph. Now, remember those cubed roots? This is where you're going to want to use them. Let's look to see where x plus 2 is equal to negative 1, because I know the cubed root of this is going to be negative 1. So this is true when x is negative 3. So when x is negative 3, y is the cubed root of negative 3 plus 2, or the cubed root of negative 1, which is negative 1. All right, what about where x plus 2, what's my next one, negative? Negative 8. X is negative 10. So when x is negative 10, this becomes the cubed root of negative 8, or negative 2. Now let's go positive. where does x plus 2 equal 1? Well, where x is negative 1. So when x is negative 1, x plus 2 is equal to 1. The cubed root of 1 is just 1. And finally, where does x plus 2 equal to 8? So that's where x is 6. So when x is 6, this becomes a cubed root of 8, which is 2. Now let's see if I can graph all those points. All right, I have my curve here. So if I were to graph, I don't have negative 10 on here. Negative 3, negative 1 lies nicely. Negative 2, 0. That's that inflection point that got shifted. Negative 1, 1. And 6, 2. So you're going to have this nice curve. All right, I'm having trouble with my pen here. This is the original y equals the cubed root of x. So this curve is a horizontal shift left 2 units. Let's look at a vertical stretch. Suppose for this problem, I have y equals 3 times the cubed root of x. All right, the inflection point is going to be when x equals 0, so that's nice and convenient. I'll make my table of values, x, y. So I'm going to put my inflection point when x is 0, y is 0. And now I'm going to want to pick points on either side. So I know the cubed root of negative 1, and I know the cubed root of negative 8. I know the cubed root of 1, and I know the cubed root of 8. So I'm picking these so that I can do the cubed root easily. So when x is negative 8, y is 3 times the cubed root of negative 8, which is 3 times negative 2, or negative 6. When x is negative 1, y is 3 times the cubed root of negative 1, which is just negative 1, so this is negative 3. When x is 1, y is 3 times the cubed root of 1. It's not writing. So that's just 3. And when x is 8, y is 3 times the cubed root of 8, which is 3 times 2, which is 6. So when I graph these, along with my y equals the cubed root of x function, I don't go to negative 8. See, I told you we don't go that far particularly often. When x is negative 1, this function comes down to negative 3. 0, 0. So the inflection point stays the same. 1, 3. And then I did include this. 8, 6. So you see you have this vertical stretch factor of 3 from the original function, from the parent function. Vertical reflections are actually quite a bit of fun. Let's look at the vertical reflection here. Y equals, where's my pen? There it is. Y equals minus the cubed root of x. That minus sign is way out front. Just didn't show up very well. All right, when I graph this, let me go and grab up the graph here. I see that when the origin will map to the origin, the point 1, 1 will map to minus 1, 1 minus 1. So we're going to get this part of the curve. When x is 8, the cubed root of 8 is 2, and this will map to negative 2. So you're going to get this very nice curve that looks a good deal like you've put a mirror across the x-axis. What about a horizontal reflection and a shift? So we're just going to mess with you a little bit here. What about when I give you something like y is equal to 2 minus x, okay? And this is all cubed root. Let me rewrite this as a cubed root of negative x minus, plus 2. When I write it this way, you see you have a horizontal reflection because you have that negative. And then this is going to be a horizontal shift. Left 2 units. All right. I'm going to go ahead and bring up what this looks like. So I give myself a little room to work. Now, the first thing you're going to want to do is find your inflection point. To find your inflection point, you take what's under the radical and set it equal to 0. So minus x plus 2 equals 0 when x is equal to 2. So when you do your xy, all right, the point that goes in the middle is 2, and that's going to go to 0. So we'll graph the point, x equals 2, y equals 0. Now from here, you really don't need to sketch a whole bunch of points if you can recognize that you have not just a shift, but a reflection. And this is going to be a horizontal reflection. So while we have this original curve starts from the inflection point and goes up and to the right, a horizontal reflection will start at the inflection point and go up and to the left. Let me try throwing in a few more points. When does minus x plus 2 equal to 1? That is when minus x is minus 1 or x is equal to 1. So when x is equal to 1, y is the cubed root of 1, which is just 1. So we'll have the point 1, 1. When is minus x plus 2 equal to minus 1? Well, that's when negative x is equal to negative 3 or x is equal to 3. So when x is equal to 3, the function is equal to the cubed root of negative 1 or negative 1. Now, if you have the general, now you can sketch just knowing the general shape of your cubic function.